did. Okay, can you all see the parabola? I had the computer graph this function, right? If we go to an x value of -1, now it's way up there, so maybe I'll have to zoom out just a little bit. Come on. What the heck? There we go. All right, can you all see? This is our x-axis up here. If we go to -1 and we come down, we should be down here at, what was it? I thought it was -12. Was? 8, -12 should be down. Did I type it in wrong? Plus 2x minus 7.
Yeah, but you're looking at the wrong place on the grid.
Each grid space is 2 grid spaces.
Is it?
Yeah.
Yeah, but -12 is right here, right?
Yeah.
Oh, you're saying, oh, got you. Oh, duh. It's -2 here. Sorry, this is -1. That's what. All right, there's -1. We come down, here's -12. Here's our point, right? Yes? Okay, I'm gonna move this up so we can see something. Okay, so this is actually our point. What is the slope of the tangent line there? 8. But we just found the equation of the tangent line, right? So if I ask this computer to graph this line, what should happen? I should draw the line that goes right through that point and is tangent to the curve. Let's see if it happens. So it was 8x minus 4. There it is. See? We just found the line that goes right through that point and runs tangent to that curve. And this is it right here. Make sense? Okay, I've got a little bit of time left. I'm going to pass around the sign-in sheet. So make sure you sign in for today. So I've got some good news. The good news is that we have suffered a little bit through these limits. They can be a little confusing, but in business calculus, that's about all the suffering you have to do. And now what we do is we give you some very, very nice shortcut formulas so that you don't have to do the limit in order to get these answers. You can do something completely different. All right? So I want to introduce you to this. This is the next section. Where's the sign-in sheet? I just want to check something. When is your first exam scheduled? It's on the other side of that. February 20? Okay, we've got lots of time still. So this is 10.5 in the book. Basic derivative formulas. All right. So here's the first one. The first one I'm going to give you because I think it's the most important one. It's called the power rule. star, star, star here. Super important rule. So the idea here is this. If you're a business student, right, and you're having to try and figure out highest and lowest points on graphs, you don't want to be sitting here doing the limits all day, right? Because they're computationally, they're difficult, especially if your functions get more complicated. So there are rules that we've come up with that will allow you to take derivatives without having to do limit at all. And here's the first rule that you can use. It says if your function has x to a power n, all right, then the derivative of this function at a is n a to the n minus 1. Now that may look like a weird formula, but it actually is a very, very easy formula to use. And I'll show you with an example. As an example, let's say we take the function f of x equals x to the 5th power. Now we didn't do this one, but I could have asked you to find like the derivative, the slope of the tangent line at like different points, couldn't I? Right? And if you did this, you would have to do the limit in there. And you would have to do f of a plus h and all that, and you would have to plug a plus h in here, and it would suck, because a plus h to the 5th power would suck, wouldn't it? But this rule says if you want to know the derivative at a, all you have to do is take the power here, you see that n? And bring that power out front. And then subtract 1 from the power that was there. So I bring the 5 out front, a, and then I subtract 1 from that power. And this is just 5a to the 4th power. And that's it, I'm done, no limit. I don't have to do a limit. Amazingly, that's the answer. Yes?
For f of a, what's the difference between like putting the derivative
With x? Okay, yeah, I haven't got to that yet. I'm going to. Yeah, because I haven't talked about f prime of x yet and what that means, right? Is there even a difference? You're asking me why am I not putting f prime of x? I'll get to it. Yeah. Okay. That makes sense? Very, very clean rule. Any questions on it? Okay, we have another rule. Not yet. Constant rule. And it says this. If your function is a constant, now I'm going to use c for a constant, so that means if your function is like 5 or 7 or negative 10, but there's no x's in it, it's just a number by itself, then the derivative of this function at a is 0. Now here's why this happens. If your function is a constant function, isn't it flat when you draw it? Isn't it flat? And what is the slope of the tangent line at any point on a flat line? It's 0, right? And that's what that's saying. You with me? Okay, and the last one that I'm going to need, so I have 5 more minutes. So I can conclude today is the sum and difference rule. And it says that if you have two functions, f of x and g of x, if you add them together or subtract them, it doesn't matter, then f prime of a plus or minus g prime of a. In other words, if you have two functions being added together or subtracted, and you want to know their derivative, you just take the derivative of each one and add and subtract the answers. I'm going to illustrate this right now, all right? Okay, what was the first example I gave you today? What was the first example? First example was 5x plus 3. Remember that? And I said, hey, let's go find f prime of a. And we did. What did we find out f prime of a was? 5. I'd like to show you how I could have gotten that answer without the limit now. Right? Here we go. Do you see that this function has two pieces being added together? Yes? This rule says that if I have two things being added together, I can do their derivatives separately. So I'm going to look at these individually. On this first one, do you see that this is x to the first power right here? Yes? Okay. Since that's x to the first power, I can use the power rule. The power rule says that the derivative of this, I should bring the 1 out front. What's 1 times 5? 5. So I have 5. And then I should have x to what power?
0.
I subtract 1 from there. 1 minus 1 is 0, right? So x to the 0. That's the derivative of this, right? Plus, now what's the derivative of a constant? 0. All right, one more thing to notice. What is x to the 0? It's 1. X to the 0 is 1. Any number to the 0 is 1. Now, if that's a little confusing, you can just do this. 2 cubed is 8. 2 squared is 4. 2 to the first power is 2. So what's happening every time I come down by a power? It's half, half. So the next one, 2 to the 0, should be half of this, right? Should be 1. It makes sense if you do it this way that something to the 0 is 1. So this x to the 0 is 1, isn't it? Which means that this is just 5. And we're done. What was the last example that I had you work on by yourselves or together? That was f of x, negative 3x squared. Oh, you know what? Hold on. This should have been an a here. Pardon me. That should have been a. Okay. What was it? Minus or plus? Plus 2x minus 7. Okay. So now, if I want to find f prime of a, what I'm going to do is I'm going to bring this power right here. There's 3 different pieces, right? 3 different pieces? I'm going to bring this power out front. 2 comes out front. 2 times negative 3 is negative 6. Now I'm using a, not x. So a to what power? No, be careful. I'm subtracting 1 from this. So just a to the first power. Make sense? Okay. Over here I do plus. Now this, there's a 1 up here. So bring the 1 down, that's just 2. And then x to what power? 0, that's going to be a 1, isn't it? And then minus, what's the derivative of a constant? 0. I did x again, damn it. You shouldn't have said anything. Now I'm... Okay, so this should have been a. Now, a to the first power is a, so we get negative 6a, right? And then this was 1, so we get plus 2. And that's the same answer you got, right? That's where we're headed. I'm going to give you a bunch of rules, and then we're going to be able to do derivatives of lots of different functions in the shortcut. So on the test, you will have to do at least one derivative with the limit, okay? The way we did it in class today. And then after that, I'll let you use the rules. Okay, have a good weekend. Do your homework for the section on 10.4. Do your homework for 10.4. I'll have these quizzes graded for you next week, the ones you turned in last time.
I have a super quick one.
Yeah.
I think it was 30. When you have a negative 4 and a positive 4, I think it was right here. What do I do? Because it's 1, 2, 3, 4.
Wait, which one are you looking at?
Number 30. What would I do when there's not a point and it's like that?
1, 2, 3, 4. Then you imagine that it's solid. Okay, so if it goes like that, here's the axis, right?
Yeah.
It looks like there is a point there, right? There's not a hole?
There's not, it doesn't have anything.
It doesn't. So if it's not there, then assume it's like a point.
So like-
See, all of these are points, okay? They're all points. But you don't want to highlight every point.
Of course.
So you just, so if it doesn't have a hole, then you can assume that it's a point.
Okay.
right?
And then for 73, okay, this one didn't have, why was it 73?
I'm going to turn my camera off. Is that from last time?
Yeah.
Okay.